Welcome back to class. To get started, let's just briefly go over what we discussed last time. So we spent the majority of class going over homework 4, which was a homework assignment for large-scale machine learning problems. And I've uploaded the solution to Canvas so that you can download my files and compare them against yours. So I'd be curious to see where my code is slow, where your codes are faster, and you might have an interesting learning experience by doing that comparison as well. So download those files and compare them against yours. And then we just started discussing the minimum spanning tree problem by defining an integer program for it, but we didn't get to program it. And very briefly, I mentioned preparing for homework 6. So this is your last homework assignment where I'm going to give you a paper to read, and it will be your job to essentially implement the complex custom optimization algorithm described in that paper. So the plan for today is I'd like to just highlight the paper that you should read for homework 6. You should read this before next Tuesday so that when you come to class, we can start discussing the algorithm, and you can ask the various questions that you might have about that. And the rest of the plan for today is to tell you a little bit about special methods in Python. So far you know about one special method, which is the init method, right? So that's the method that we put in a class, and that's the first thing that gets called to create an object of that class. But there's many other special methods in Python, and they're incredibly useful, and they might be quite useful for you for homework 6, and that's why we're going to cover them today. And then towards the end of class, we're going to go over the pandas group by statement. So this is a part of pandas that we didn't cover in detail previously, but it gives you a tremendous amount of power to process complex data sets very quickly. So that's the plan for today. Let's just begin by looking at the paper that you should read for homework 6. So you can find this paper just by going to Google Scholar and searching. So it's called an exact algorithm for the elementary shortest path problem with resource constraints. So if you click here and you're on the UT network, you should be able to download a PDF of the paper. And so this is the paper. I'd like you to read over all parts of it. Just to give you a brief introduction to what the paper is about. It's about routing a vehicle over many locations. So you can imagine that each one of these nodes is a location. And the vehicle needs to perform some tasks at these locations, and these tasks consume some resources. So resources might be things like volume in the vehicle if the task involves picking up or dropping off things, or it might be time, or it might be gasoline, or various other things. And so the question is how to order these tasks in such a way so that we minimize the overall cost while satisfying certain resource constraints. But please read this paper and bring your questions to class next time, because for homework 6, you have to implement this algorithm. And essentially, I intend no discussions of this other than answering your questions. Because the basic task and the thing that I hope that you get out of this homework assignment is the ability to pick up a research paper like this and implement the algorithms on it. So this is a skill that's important both for industry where you might go and for your individual research topics, regardless of whether they're master's research topics or PhD research topics. So let's get into the second part of class, which is looking at the special methods in Python.
Python defines these special methods so that your classes can interact in a rich way with built-in functionality of Python. You're already familiar with some of these. For example, you're familiar with this init method that gets called to create an object of a class that you've defined. And in today's video, we'll learn about a few more of these. Some that allow you to represent your object in a pretty way in Python, that let you compare your objects, that let you hash your objects and put them into dictionaries, and things that let you compute attributes on the fly at runtime. All of these things are very well documented online. If you just look up Python special methods, you'll be taken to this page that's just the Python data model, And here you can find all kinds of documentation on these. For example, you can just look up the init method, and it'll describe to you what the init method should do. So let's just begin learning these with a really simple example. So here I've defined a class that's a car, and this car class has just one special method right now, just the init method, that takes in a color and whether the car is expensive, and just stores those two things on the car object. And here I'm creating two cars, a jalopy that's teal and inexpensive, and a speedster that's red and expensive. So let's just paste this into Python to play with it a little bit. So if I try to just take a look at the jalopy object I created, what you'll see is that Python prints out a couple of things. First, it prints out this string, main.car, and what this means is that this is an object that corresponds to a class that's in the main module, and it's the car class, and this object is on this memory address. So this is some information that gives you at least the data type of the object and where in memory it's located. And if I display the speedster, it's from the same class, it's from the same main.car class, but it's at a different memory address here. But of course, this is not a particularly beautiful representation of the object, and it's also not a very meaningful one, because maybe to me what's more important than the memory address of the object is the color of the car and whether it's expensive or not. So let's add a special method onto our car class to make these objects display in a nicer way. And we're going to do that with the representation method, or repr. And all this method takes as input is just the object itself, just self. And what it should return is the string that's the string representation of this object. So let's build this up. This is going to be a car. Its color is going to be something. So here it is. I've just put the car's color into the string, and then I also want to add whether it's expensive or not. So let's do that. And here we just are going to return that string we created. Now let's paste this new code into Python and see how it behaves differently. Now when I take a look at the jalopy object that I've created, instead of getting just this uninformative memory address, what I'm getting is that this is a car, its color is teal, and it's inexpensive. If I look at the speedster, I'm getting that this is a car, its color is red, and it's expensive. Now this is exactly the string that I returned in that representation method, and this is useful in lots of ways. So for example, if I try to turn our jalopy object into a string, the string that it gets turned into is that string that I returned, or if I try to print a jalopy, what it prints is that nice representation of the object that we created, that this is a car, its color is teal, and it's inexpensive. So this is a really nice way of just getting more informative representations of your objects to show up in Python. Let's take a look at some of the other special methods. So the next thing, suppose that the next thing I want to do is basically have a list of cars and be able to sort them. To be able to sort them, I have to be able to compare one car to another to say which is preferable. And let's say that what I'd like to do is be able to just say that a speedster is better than a jalopy by just doing this less than sign in between them. So I'd like this to return true to tell me that I actually prefer the speedster over the jalopy. And intuitively you can think of lower valued things are things that we prefer. So right now it's saying false for the speedster less than the jalopy. And the reason that it's saying false is because by default, these comparison operators, all they do is they compare these memory addresses here of the different objects that you created. So it's not a particularly meaningful comparison. And so let's go and write some code to create a meaningful comparison between these car objects. So to do this, I'm going to define just 3 functions. So the first, I'm going to define a less than function that takes in this object and another object. And it's basically going to return true if I prefer this object to the other object. So let's do that. So if this car is expensive and the other car is not expensive, then I'm going to return true, because in general I'm going to prefer expensive cars to inexpensive ones. And if this color is red and the other's color is not red, then I'm going to return true, because what I really prefer are red expensive cars. And let's say that in this case what happens is I just prefer cars based on the alphabetical sort of their colors, as long as they have the same expensiveness. So if self-expensive is the same as the expensiveness of the other car, what I'm just going to return is self-color less than others' color. And otherwise I'm going to return false. So the only way that I prefer one car to another is if this car is expensive and the other is not, this car's color is red and the other is not, or they have the same expensivenesses and one has a lower alphabetical value for its color. The next method we're going to define is an equality method that just says whether 2 objects are equal. And they're only going to be equal if they have the same expensiveness and color value. So far all I've done is define this basically corresponds to the less than operator that you're familiar with. This corresponds to the equal operator that you're familiar with. And I want to define all the other ones. And these 2 are sufficient to define all the other ones. So to define all the other ones, I'm going to define this CMP function that just defines all of these things at once. And if you just look up the definition of this function online, you'll read that this should return a negative integer if self is less than other, 0 if they're equal, and a positive integer if self is bigger than other. So let's do that. If self is less than other, we're going to return a -1. If other is less than self, I'm going to return a 1. Otherwise, I'm just going to return a 0, because neither one is better than the other. So the reason that I did this is because when you have this less than operator, what happens is the less than function gets called on the left argument. So here, other is going to get passed into the less than operator of self, and here, self is going to get passed into the less than operator of other. So I'm using this function twice, basically. Once here on self, and once here on other. Okay, so let's cut paste this and see what kind of behavior we're getting. So let's check if the jalopy is better than the speedster, and it's not. Let's check if the speedster is better than the jalopy, and it is. Is the speedster the same as the jalopy? No. Is the speedster less than or equal to the jalopy? Yeah. So this defined a rich, nice comparison between different cars. So let's use it to just sort some cars. So here I have an expensive red car, that's the speedster, a teal inexpensive car, that's the jalopy. And let's create a azure jalopy. That's going to be a car, it's going to be azure, and it's going to be inexpensive. And let's put all of these in a list. It's going to be, let's say, the azure jalopy, the jalopy, and the speedster are going to be in my car list. So notice that when I just print out car list, I'm getting the nice representations here the azure inexpensive car, the teal inexpensive car, and the red expensive car. So let's say I want to sort these. So if I call Python's built-in sort method with my car list, what's going to happen is all these cars get sorted in the way that I defined the less than operator. So I'm getting the red expensive car as being the best one, the smallest one, it comes up at the top of the list. Then the azure inexpensive one, because I like the azure inexpensive more than the teal inexpensive because of the color comparison. This color starts with A and this one starts with T. And so now I have a nice way of sorting a car list without ever having to define my own sort function, just using Python's built-in sort function. So this is extremely useful for defining all kinds of operators and using all kinds of built-in functionality inside of Python. Okay, so now you're familiar with both repr and CMP that lets you compare your own objects. So let's take a look at the hash operator. In particular, why is this useful? So hashing is something that just takes a Python object and returns a number. So for example, if I just hash the word hello, I get a number. But if I hash a different word, goodbye, then I get a different number than when I hashed hello. And these numbers basically get used by Python dictionaries to determine where this particular object should get stored in the dictionary. In other words, what determines whether we can use an object as a key inside of a dictionary is exactly the ability to have this hash function. So I can hash the tuple 25, but if I had a list 25, it says that it's an unhashable type. So lists you cannot use as keys to dictionaries, but tuples you can. And in just a little while, we're going to understand a little bit more about why that is. But let's take a look at what's happening with our cars. So if I just take a hash of the jalopy, it gives me a particular number. But let's create another car, jalopy 2. It's going to be teal, and it's going to be inexpensive. So here's our original jalopy, and here's jalopy 2. And when I hash jalopy, it gives me one number, and when I hash jalopy 2, it gives me a totally different number. So when I create a dictionary, and let's say that I use jalopy as a key into the dictionary, and then I use jalopy 2 as a key into the dictionary, and then just print out the dictionary, you'll notice that now I have two things into my dictionary. So one is, for this teal inexpensive car is the key, and the value is 1. And the second is a teal inexpensive car with the value of 2. But this may not make sense based on your application. In particular, to me, jalopy 1 and jalopy 2 might in fact be the same thing. They might be the same car, the same object, even though I created them in two different places, even though they have different memory addresses. And so what I actually wanted when I executed this adict of jalopy 2 is actually just wanted to change the value of the teal inexpensive car as opposed to storing an entirely new value in there. So let's change this functionality so that when I put jalopy into a dictionary and then try to change the value by putting jalopy 2 in there, it'll actually change the value as opposed to entering an entirely new entry into the dictionary. So just to again highlight what's going on here is that these two cars, jalopy and jalopy 2, are in some sense the same car. They're just a teal inexpensive car, and so I don't want two entries for them in the dictionary. So let's fix that. So to fix that, what we're going to define is a hash function. And all this function does is it takes the object and should return a hash of that object. So what we're going to do is just return hash of this tuple, let's say self-expensive and self-color. So previously, the reason that Jalopy and Jalopy2 return two different numbers here is because by default the hash function, what it does is it just takes a hash of the memory address of the object. Here I've changed that so that the hash function, instead of taking and looking at the memory address of the object, what it just does is it just takes a look at whether that car is expensive and the car's color. So let's paste this into Python and see how we've changed the behavior. Let's create Jalopy2. It's going to be teal and inexpensive. So now when I take a look at a hash of our Jalopy car, it returns one number. And when I take a look at a hash of Jalopy2, it actually returns the same number. But these objects are actually different objects in memory. And the way you can see that is if you just call ID on the object, you're going to get different numbers. And ID is just a way of getting back to the memory address of that object. So even though these are two different objects in memory, they actually return the exact same hash value, and that's because we defined hash to just look at the expensiveness of the car and the color of the car. So what does this give us in terms of dictionaries? Well, now if I have a dictionary, and somewhere inside the dictionary I just put Jalopy with a value of 1. So here it is. Here's the dictionary. This is the Jalopy car, and its associated value is 1. And now if I take Jalopy2 and I put in another value, let's say 10, and I look at the dictionary, what happened is I didn't create a second entry in that dictionary. Instead, all I did is I went to the first entry and I just edited its value to 10. And this was because both Jalopy and Jalopy2 actually hashed to the same number. So the dictionary knew that it should actually just take a look at that same particular memory location for the value of those two objects, as opposed to different memory locations for the value. Okay, so hash is particularly useful. The way to think about it in summary is that it's particularly useful if you want to use your objects as keys inside of a dictionary. Then you should probably write a hash function to do that. And if you read online, you'll find out that the dictionaries actually use both this hash function and this equals function to determine if two objects actually should map to the same value. So they both have to return the same hash, and they have to be equal as defined by the equal operator. So both of these two things actually get used to make sure that Jalopy and Jalopy2 actually should be the same spot in the dictionary. Okay, so let's take a look at our last set of special methods here, which are getAttribute and setAttribute. So suppose that we want to have some attributes that are just computed on the fly. So we're going to do that with getAttribute. And getAttribute just takes in the object and the name of the attribute that somebody's trying to get. So what I mean by this is somebody might do something like jalopy.cool. And they're expecting the cool attribute to be on this Jalopy object, but it's not there. And so it tells me that car object has no attribute cool, and so it gave me an error. So let's fix that and say that red expensive cars are cool and that other cars are not cool, but we're going to compute this on the fly. So the way that we're going to compute this is we're going to say if name is cool, and if self.expensive and self.color is equal to true and red, then we're going to return true, and otherwise we're going to return false. And otherwise, somebody's trying to get an attribute that's other than cool, and we're going to raise an attribute error that just says car object has no attribute whatever it is that the person asked for. Okay, so let's cut paste all of this in here and see how we've changed the behavior. So now if I look at jalop, so one thing I'd like to point out is that nowhere in this code, nowhere in the init code, nowhere else have I defined a cool attribute. But what happens when I call jalopy.cool is this get attribute method gets called with the word cool as a string parameter right there. It's going to check that name is actually equal to cool and execute this code to return either true or false. So the jalopy is not cool, but if I look at the speedster, then that one is cool. So this is a dynamically computed attribute that's getting computed on the run when I ask for it. And if of course I call something else like jalopy.old, it's going to give me that error that the car object has no attribute old. So you'll notice that this is coming from the piece of code that I wrote that's right here that just raises this attribute error if the attribute that getAttribute got was not cool, it was something else. So I'll similarly get something if I call, let's say, jalopy.new, so car object has no attribute new. So basically, getAttribute gets called whenever the attribute is not found on the object usually. So I could still access jalopy color and jalopy expensive, but if it's not on the object, then getAttribute will get called. By the way, a useful thing to know is that you can call these directly. So for example, I could just call getAttribute on the jalopy and then pass in a particular word here like cool and it'll return false, or I could even pass in color and it'll return teal or expensive. And so this is just a way of getting attributes out of the particular object that you have in mind. Similarly, you can control when people set attributes on your objects. So let's do that. So this function basically gets called whenever somebody does something like jalopy.hello equals 7. So when somebody does this, setAttribute is going to get called with the name hello and the value 7. And in particular, this is also going to happen up here when I set the color of the car to color. So setAttribute is going to get called with the word color as the name and the value of this variable as the value. So let's do that. So basically, by writing this function, what I'm saying is that outside code is only allowed to set two attributes on a car, either its color or whether it's expensive, but nothing else. So let's see how this behavior is different. So before I cut paste the code, I want to show you what happens if I didn't have that set attribute code. Then I could set jalopy.old equals true, and then that just works. So this is because this jalopy object was created with a class that doesn't have that set attribute method, which we just defined, and I haven't cut pasted into Python yet. So let's cut paste it into Python and see how that changes the behavior. So I just forgot that I have to pass self onto set attribute here as well. And I just need to fix my conditions here. So if the name is color, set it. Else if the name is expensive, set it. And otherwise raise the attribute error. Now let's see what happens if I do jalopy.color equals green. Then I got to change the jalopy's color from teal to green. But if I do something like jalopy.old equals true, then it no longer works. It's giving me that attribute error. You're not allowed to set the attribute old. And so through these two special methods, through getAttribute and setAttribute, you can control the attributes that are on your object and either dynamically compute their values or prevent other code from setting attributes that it shouldn't be setting on your objects. By the way, similar to getAttribute, you can call this specifically, so I could call jalopy with color and set it equal to the value blue, and now jalopy has a blue color. Or I could call set attribute on jalopy with old and true, and it's going to give me that attribute error that we saw. You're not allowed to set the attribute old. This is just a brief introduction to Python's special methods. So just the main takeaways are: define the repr method to get meaningful representations of your objects to get printed out in Python. Use comparisons to do built-in sorting and comparisons between objects that you have. Define a hash method if you want to use your objects as keys to a dictionary. And use getAttribute and setAttribute to control access to the attributes of your objects. There are many, many other special methods that you can read about online. For example, there are things like add, subtract, multiply that let you define how the basic operators work on your objects. For example, adding two cars together, what might that mean? Or multiplying two cars. Maybe this doesn't make sense for cars, but if you have some particular mathematical object in mind that you're working with, it might actually make sense to define these particular operators. Read about these online should you need them, and know that they exist. But I hope that you found this useful and that you think about perhaps using Python's built-in special methods to help you in your future development projects. I'll tell you a little bit about the pandas group by statement. I hope that this statement is useful to you in your future development or research projects. So just to get us started, this is a data file that you might be a little bit familiar with because we saw it in class earlier in the semester. In this data file, I just have last names here, things like Smith, Johnson, Williams, and so forth. The percentage of the population that has that last name, the cumulative percent, which just adds up these percentage numbers as we go along, and then the rank of that last name in the population if you just sort them from most popular to least popular. Now we're just going to start with this data set, but the question that we're going to ask is, what percentage of the population has a particular first letter of the last name? So I want to know what percentage of the population has a first letter S in their last name, what percentage has a first letter J, and so forth. And we're going to use the pandas group by statement to do this. So let's begin by just importing pandas and SciPy, and then just reading in the data frame. So here's our data frame. It's exactly what we saw in this spreadsheet. The first few rows are just Smith, Johnson, Williams, and so forth. So the group by statement is just on a data frame. And you can read the documentation for it, and the documentation is extensive, like most other complex functions in Python. But the most important part here is the by parameter. And you can read the documentation here. It's a mapping function, or a list of functions, or a dictionary, or a series, or column names. But the way that it's most useful to think about this is that the by parameter returns a value, and the data frame is split based on that value. So the most common and easy way to do this is by passing in just a single column name. So to do this, let me just create a new column here. So let's say new column is just going to be equal to 0. But let's say that I'm going to say that in locations where the surname starts with S, or the surname is null, new column is going to be equal to 1. Now let's take a look at just those first few rows of the data frame. So this is the new column we created, and it's 1 in all the locations where the surname starts with S, and 0 for all the other locations. So the reason I did this was just so that I can pass in new column into group by. So let's do that. So by is just going to be just new column. And that returns something called a pandas group by object. And this object has a lot of things on it, but maybe some of the most useful ones are groups, which is a dictionary. And I'm not going to print groups because it's a very big dictionary in our case, but let me just print out the keys for groups. And the keys are two things, the number 0 and the number 1. And these keys come from the values that this by function returns. So new column only had two values, just 0 and 1. And that's why we had the corresponding two keys 0 and 1. And when I look at answer groups sub 1, that returns all of the indices in the original data frame that correspond to that particular value. So these are all the row numbers of last names that start with S. So just to connect this a little bit more, if we look at this, I mean these numbers right here. That's what groups 1 is returning. So this is just row numbers, but let's pull out just the entire data frame rows of all the last names that start with S. So to do this, we're just going to do answer locations, data frame locations that correspond to group 1 of answer, and we're going to take all the columns. And as you can see, these are all the last names that start with S. And similarly, if I looked at the group that corresponded to the key 0, then it's going to be all the last names that correspond to non-S last names. So that's the simplest use of the group by statement. But of course, we want to do something more complicated. So let's go back to how we called it. So here, in the simplest use, we just passed in a column name, and that grouped the data frame by values in that column. But instead of doing this, what we're going to do is we're going to pass in a little function, and then the data frame is going to be grouped by that function. So here I'm going to group by surname get 0. So before I execute this, let me just show you what this returns. So get 0 just accesses the first letter of that surname column. So this was Smith, Johnson, Williams, and so forth. So let's call data frame group by, where we're grouping by surname the first letter of surname, and let's store that in a variable that we'll call answer. So if now I look at the keys of that group's attribute of answer, the keys are all the different potential first letters. So A, C, B, E. So these are not coming in any order, of course, because this is a dictionary, and dictionaries don't have a particular order to them. So, but these are the keys in that dictionary. It's all the potential first letters. So these are all the different things that the function we passed in this get actually returned. Okay, so if I wanted to get all of the last names that begin with A, I could do a similar exercise as before, and I could just look at data frame locations and look for groups that correspond to the key A, and take all the columns, and there are all the A last names. Of course, all the A last names, the new column is going to be 0 because we made new column to be 1 just for the S last names. So let's take a look at the S last names, and their new column is 1, and of course any other letter like B or something like that. These are all the B last names. Their new column is going to be 0. But okay, so this is how we took that big data frame and we quickly broke it down by the first letter of the last name. But our question was, what fraction of the population has a last name that begins with B? And to do that, I basically have to take this data frame of all the B's and sum up this percentage column. And I have to do this for the A last names, the C last names, and all the rest of the first letters. Now, writing a little loop to do this would be, you could do it. It would be reasonably complicated, but not too complicated, only 2 or 3 lines. But the group by statement has that capability built in. So let's use that. And in particular, that capability is in these functions, ag and aggregate. So let's just take a look at ag. For this function, you pass in the way that you want to aggregate. So this is a function to use for aggregating groups. If a function, it must either work when past a data frame or when past a data frame apply. If past a dictionary, the keys must be a data frame column name. So the way that we're going to use this is we want to aggregate that. We're going to use this dictionary first functionality. We want to aggregate that percent column. Right, so this was the column that we wanted to sum. And what we want to do with that column is we want to sum it. So I'm just going to pass in scipy.sum as the value corresponding to that particular column name. And when we look at the answer that gets returned from doing this aggregation, the indices here are just those first letters of the last name. So that was the A, B, C, D, and so forth. And then these are the percentages associated with them. So A has 2.6%, B has 7.3%, and so forth. So let's store that in something that we call, let's say, aggregated. And let's just sort aggregated based on its percent column, with the biggest number on the top, and let's do it in place. And now if I look at aggregated, it tells me that the most popular first letter of the last name is M, and that's about 7.7% of the population. The next most popular is S, that's 7.3% of the population, then B with 7.3, C with 6.2, and so forth. And the least popular ones are Q, U, and X, with each about 0.1% or less. So this is the pandas group by statement. It's extremely useful, and it works much, much faster than writing the corresponding for loops by yourself in Python. And for those of you that are familiar with SQL, the group by statement directly corresponds to the group by statement in SQL query languages that you might be familiar with. And so it's something that's just very, very useful when working with data sets. So I hope that you find it useful in your future research or development projects. Thank you very much for listening.